Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage ESR et décollage. Propulsion nominale, le pilotage est calme. La trajectoire est nominale. Pilotage calme. La trajectoire est calme, les paramètres à bord sont nominaux.
The next 32 satellites.
Propulsion nominale.
The next 32 satellites for
Pilotage
Amazon
calme.
Leo have started their journey on board the first Ariane 6 with 4 boosters. Wow, and that was a
La
beautiful
trajectoire est
launch.
nominale, les
What a
paramètres à bord sont nominaux.
Magnificent liftoff. We can hear Ariane 6 passing by and feel the walls shaking. Wow.
It's taken just around a minute and a half for the sound to get to us.
How powerful that was.
Looking here
Pilotage
at
calme.
the coast of the Amazon rainforest, the coast of French Guiana moving away from us. Those are the onboard cameras. I'm guessing that's the river Kourou, that line on the land that we can see. You can see the clouds moving away behind us. We are burning 5 engines. We ignited them all on the ground, but the boosters are doing all the work for us right now, aren't they?
Most of the work, yeah, indeed, as you said. So remember that the weight of the launcher was 870 tons on ground, and so 90% of the thrust is delivered by the boosters. They'll burn 142 tons in 2 minutes 25 seconds. So we are actually burning 4 tons of propellant each second now.
Séparation des ESR.
And we just had confirmation of the boosters separation.
We're seeing the images from the live cameras a few seconds later, and that's perfectly normal. That's for technical reasons. But look, that's how it looks. And they're falling away in perfect formation.
Yeah, and this is to be precisely set and analyzed and checked because, of course, you need the boosters to be jettisoned quite quickly, but not well in a mastered way to avoid any collision, any risk. Wow, nice shot from the onboard cameras.
Our planet Earth. And the next big moment on the left-hand side of your screen, you can see the events coming up, will be the jettisoning of the fairing. That's the nose cone, if you like, of the rocket,
Séparation des
which is
coifes.
protecting our satellites. And we've had confirmation that that's now been separated. We'll see the images hopefully on the camera.
So it was long fairing today, first flight for these two halves, 20 meters. Whoa, you can see the fairing being jettisoned here.
And you can see how it flexes as it falls. That's all part of the plan.
Yes, indeed, and that's a beautiful movement, but it's due to the fact that it's designed to be as light as possible, but of course, when separated, the loads are pushing it, and it's being deformed due to its stiffness. This creates this movement, what we call a breathing mode. Nice breathing mode here. All designed to sustain that, of course.
Our altitude, 161 kilometers down at the bottom of the screen there. Our distance from the pad and our speed, vitesse is the French word for speed. At the moment, we're traveling at nearly 3 kilometers per second, everybody, per second. And the range operations manager is telling us that everything is going well and everything is going according to plan. Now, I'm rather hoping that Ariane is back with us because we sent him out to go and watch the launch with his own eyes on the terraces. Ariane, what was it like?
Oh, what a magnificent errand. It was like watching a second sunrise. I've never seen flames coming off an Ariane rocket like that, and it was a delight to watch the mighty Ariane 6 rise majestically from its throne before plunging into the vault of the heavens. It was astonishing.
I'm so glad you were able to go and see it, Aaron. It's very powerful, this beast, Ariane 64. So we're burning the main stage. Now you can just about see the sort of main stage at the bottom of the screen there of the rocket. It's, as Aaron was telling us earlier, it's a great big tank of fuel.
Yes, indeed, it's quite tall. You can't barely, well, you can guess, but from the onboard camera it seems tall, but it's still 32-meter high, diameter 5.4 meter, and we are currently burning the 154 tons of liquid oxygen and hydrogen, as Aaron was discussing earlier. And why are we using these two? This is because the chemistry of these two elements makes that it's one of the most, let's say, fuel-efficient combination that exists to convert that into thrust and hence velocity given to our passengers, the Amazon LEO satellites.
He's telling us that the propulsion is nominal, so everything's going well.
Yeah.
And we separated the boosters using cutting-edge technology called optopyro.
Yes, indeed. These are key technology based on laser pulses sent through optical fibers, and they are used to trigger key pyrotechnic events such as the booster separation, which we've just seen. And next step, and next they will be used for separating the main stage.
So we've just heard there from the range operations manager that we've picked up the signal at the tracking station SNA, he said, which is actually a naval tracking station. So as Aaron explained to us earlier, we're tracking the rocket using telemetry. There are ground stations dotted along our flight path, and the rocket's basically is talking to us. It's sending signals as it flies over. The naval tracking station, Aaron, it's in a boat, isn't it?
Yeah, the ground station is on the water. Kind of funny to say that, but yes, it's in the Atlantic, in an area that has a telemetry hole, so we send a boat to that area to track the rocket during its overflight. It has a 5-meter S-band antenna, and it's mounted on a stabilized platform, so if it's wavy, it can have a clear view of the rocket.
Coming up now to the next main event, which will be the extinction of the main engine.
Extinction Vulcain et fin de mission sauvegarde.
And we have confirmation there that the
Indeed, yeah.
engine is switched off.
It was just then confirmed that the main stage has been separated as well.
Allumage du moteur Vinci.
And I'm so sorry to interrupt you.
No, and I was to say that the Vinci engine has been fired up, and you can see from the onboard camera the separation of the main stage. Wow, it looks amazing. This again is a very precise step of the flight, and a very key step where you need this stage to be separated gently but quickly enough to ensure the Vinci can fire up.
It looks easy, but actually what's happening up there is unbelievably carefully planned. It's the result of very clever brains. And there he's telling us that everything is going normally. So the upper stage is now in charge. We can't actually see it on these shots, but Aaron, I kind of like to think of it as an orbital bus driver, because its job is to deliver our passengers to lots of different bus stops in space.